With research, there are no answers already there for you. There's no one you can really go to ask what the answer is. You have to figure it out yourself because you're really the only person who's in the position who could figure it out. It's been a great summer and a lot of fun. I think I've learned a lot as well. Above 100 degrees Celsius, copper sulfide undergoes this transition where the sulfur atoms stay in their lattice sites, but the copper atoms almost act like a liquid and they flow freely. But scientists don't really understand the atomic interactions when it's at that state. So we've been trying to figure out what exactly is going on. People have looked into using these superionic materials for making better transistors, but also for energy storage and more importantly energy retrieval. It's hard to store energy and then get it back very quickly, and so it's hoped that if you can use this phase transition to sort of mechanically store the energy, and then because it only takes about 100 degrees Celsius to cause this transition, the theory is that it would be easy to get the energy back by exciting the phase transition again.
The basic idea is for a plane to fly horizontally towards a wall, do a pitch-in maneuver, so essentially pitch up and then land vertically on the wall. The application for this tends to be in war-torn areas. It's likely that there won't be a viable landing strip to land on, whereas there will be lots of walls available. And as you can tell from this picture, this is a construction site right here around Stanford. There's rubble all around and nowhere to land, but clearly that plane is perched on the wall. So it's able to take advantage of pretty much any surface. Also, it could probably take more advantage of solar energy while it's perched on the wall. So it uses micro spine technology, like spiny toes. And I guess a simple description of them would be like little fish hooks. And basically these hooks engage the little holes on the wall. One of the projects that I worked on a lot this summer was building a launcher that would launch this plane at a consistent velocity every time. And then from then on, the autopilot takes over. It does the pitch-in maneuver and lands on the wall. The main purpose of the launcher is to find the parameters that characterize a successful landing. So yeah, after we have that, then we know what speeds to fly at, what pitch angle to use. That will give us a successful landing.
If we want to preserve our Earth, if we want to like harvest all the renewable energy and do like efficient, sustainable society, this is where the research is. This is where it lies. And like the problem right now is what we do have hydrogen generation methods, but we mostly use like fossil fuels and like other electricity supplied from other like non-renewable sources. So this summer I worked with electrophotolysis cells. Electrophotolysis happens when you have light shining on a semiconductor photoanode, and where an electron hole pair is generated because of the light. So the hole reacts with the water and the electrolyte to generate H plus and OH minus ions. And then the electron transfers over to the cathode where it reacts with the H plus ions for hydrogen generation. So the overall motivation for this project was to lower the potential barrier that's preventing hydrogen generation at an efficient rate. In order to do that, we explored nanostructure materials and nanostructure properties of titanium dioxide layered with platinum that acts as a catalyst for the reaction. When you have hydrogen fuel cells, you can when you combust it, all you get is water. And so what we're trying to do is split water, go back to water. So you never run out of the, like, it's an entire cycle and you never run out of the material.
In osteoarthritic patients, they generally tend to be either overweight or have had some sort of injury to their knee. What we were looking to find is whether elevated levels of inflammatory markers such as TNF-alpha were responsible or an effect of the osteoarthritis. What we found was that TNF-alpha levels were both elevated in patients with osteoarthritis and those who had a BMI over 25, which is generally considered overweight. If it's possible to determine whether the arthritis is a result of these elevated levels of inflammatory markers or if it's a product of the damage done by the osteoarthritis. If it is in fact a result of having elevated levels of these markers, it would be then possible to suppress the expression of those inflammatory markers and suppress the inflammation and in doing so reduce the rate of knee degradation and reduce the rate at which arthritis develops. And it's a huge problem. It's prevalent in a large portion, especially of the elderly populations.